Alright, welcome class. Today we're going to work on calculating speed. So this is timely since we just wrapped up our VEX drag race project where we simulated a quarter-mile drag race by racing our cars 100 feet, calculating the time it took our vehicles to travel that distance. So in this video, we're going to talk about units of measure, how to calculate, and then my last part of the how to calculate is what's called the flip-flop method. So units of measure, here in the United States, there's really two units of measure that we use for speed or velocity. And those are miles per hour, which you often hear a lot of cars referred to or reference their velocity in miles per hour. You'll also hear feet per second. If you go to a country where metric system is used, kilometers per hour is the primary unit of measure. Either way, though, you'll recognize that regardless of what unit of measure, we do distance per time. And if you haven't learned this before, in math speak, anytime you hear something per something, that means you're dividing. So per equals division. So how do we calculate it? So again, you need a distance and you need a time. So in our project, we were traveling 100 feet. So if we found out or were given that it took our car 10 seconds to travel 100 feet, at a high level, our speed is 100 feet per 10 seconds. But when have you ever heard somebody talk about the distance in 10 seconds, or how many miles per 10 hours does your car go? Nobody talks that way. They talk about 1 second, 1 hour, 1 minute. So we need to convert to one of whatever our unit of time is that we're using. So in this case, if we were given 100 feet in 10 seconds, it's pretty simple. We just divided 100 feet divided by 10 seconds equals 10 feet per second. Now let's say we were trying to go from feet per second to miles per hour. Sounds a little complicated, so I'm going to teach you a method, which when I was taught this back in chemistry years ago, my chemistry teacher referred to this as the flip-flop method. So it's what I've always used, so this is what I teach. I'm sure there's a million other ways to do it, but I found this very simple and easy. So the first step, we start with what is given. So in this case, 10 feet, 100 feet per 10 seconds. The next step, all the way out to the far right, we write equals and what we're trying to solve for. So in this case, we're trying to convert feet per second to miles per hour. I went ahead and I put the 1 hour at the bottom. You don't have to do that because the 1 is just understood, but for this sake, I'm going to go ahead and do it. The next step is to put in all of my conversion rates. So not requiring you to memorize these. The more you use them, the more you're likely to learn them. Feel free to Google them. But you'll go through and you'll put your conversion rates down here. So let's grab my pen tool. We're going to use red. So since I started with 100 feet times 10 seconds, and I'm trying to go to miles per hour, I know I need to convert feet eventually to miles. So 1 mile equals 5,280 feet. We're also going to have to go from seconds to hours. So in order to do that, I know, start with seconds. 60 seconds equals 1 minute. And we're still not at hours. So 60 minutes equals 1 hour. So now hours, we've got miles, we've got all of our rates or conversion rates in there. But one thing you'll notice from a math perspective, you need to be able to cancel out your units. And the way you do that is you have it in the numerator on one and the denominator on the other. So basically cross-canceling. But I got feet here and I've got feet over here. They're not in the right place. So what I need to do then is where this gets its flip-flop method name from. I need to flip or flip-flop my conversion rates so that all of my numerators and denominators cancel each other out, and as I go across multiplying, I end up with miles in the top and hours in the bottom. So I'm going to get rid of those. Let's erase all my notes. We're going to flip my conversions. And let's bring that pen back. So now I've got feet. I've got feet. And I've got feet. So I can cancel my units out. I've got miles up top, which miles is up top here. So I'm good on my distance. Now we're going to come back over here. We're starting at seconds. I've got seconds up top, so my seconds units cancel out. I've got minutes at the bottom, but I'm still trying to get to hours, so I need one more conversion. So I cancel this one out, this one, and so now I've got miles per hour. So I've got all my conversion rates in there right, but now I got all these numbers, so now I need to do the math. So now I just carried it all over. Now I need to calculate my final answer. So 100 divided by 10. This is still at the bottom, so I'm dividing by 5,280 times 60, because 60 is in the numerator, times 60 that's in the numerator. So 100 divided by 10 divided by 5,280 times 60 equals 6.81 miles per hour. So 100 feet over 10 seconds, which we originally found out in one of the previous slides was 10 feet per second, is the equivalent of 6.81 miles per hour. Using the same flip-flop method, you can also come up with some other conversion rates that you can use. And these might be helpful for your homework. 1 mile per hour, once you do the conversion, so miles, hour, leaving you with feet per minute. 1 mile per hour is equal to 88 feet per minute. If I were to have taken that one more step further and got rid of the hours, I would be left with hour, mile. 1 mile per hour equals 1.467 feet per second. So that's it for how to calculate speed. Again, distance per time, and when you're going to convert, use the flip-flop method and line up your units per measure to get what it is you're looking for. If you have any questions, give it a try, and if not, come see me if you need help. And if you have any questions or comments while watching this video, feel free to drop a comment. I'll make sure to get back to you. Thanks. Bye.